Maybe there's other factors, probably the surface preparations or the material that you're aiming at, but usually these two important factors we're looking at. One is the temperature, right? The temperature matters, right? And the particle velocity. So I think the temperature-wise, it's a lot easier to understand because when you raise the temperature, particularly once it reaches the melting point of a certain material, say metal, for example, it's in a molten, it's in a liquid format, right? It's a lot easier to deposit, right? So the higher temperature, the easier you're able to deposit your deposition, all right? Now, particle velocity is a little bit tricky because particle velocity actually basically use the kinetic energy to help the particle to deposit. So basically what we're looking at is the higher the particle velocity, the easier for particles to be plastic deformed and eventually attach onto the substrate. So it's sort of using this kind of trick of having particle velocity and then transfer that into a kinetic energy and using that kinetic energy to transfer somewhat a bonding between the particle and the substrate. Right? Kinetic energy, particle velocity, kinetic energy. Right? So here's the two things: the higher you get, you get. So on this spectrum here you're looking, there is a stream side where you just play along with particle velocity and no temperature. So that's cold spray. Right? That's called cold spray. And if you deal with temperature and then there's no less pressure, that's thermal spray. So plasma spray over here, plasma phase spray, and then high velocity. So these are so-called the thermal spray area, the thermal spray, right? So thermal spray category basically include plasma phase spray, detonation gun, high velocity oxygen fuel, and more spray. So these, you can see over here in this region, it has less particle velocity, but higher temperature, right? Higher temperature. So that's the two extreme sides. So when people talk about thermal spray, and cold spray, it is not saying that cold spray you feel cold, it's just the temperature is relatively low than thermal spray. Does that make sense to you guys? And when we say thermal spray, it's not saying that we don't give any pressure, it's just pressure is relatively lower than cold spray. Perfect, right? Now, this over here, metals and solvent and ceramic, we have to understand as a material perspective, as a material science, we have to understand is that which is a lot easier to hit the melting point. I mean, reach the melting point. It's the metal, right? Metal usually has a lower melting point than ceramic. I mean, that's understandable, right? I mean, common material, right? So you can see that's why they put metals and then ceramic, which is a composite, that's a mix of metals and ceramic that has a higher melting point. So meaning that you need a higher melting point and maybe a higher particle velocity to reach that kind of objective. Does that make sense? All right, so over here on this axis over here, we have typical feedstock powder size that has a wide range from 200 micrometer all the way from 10 micrometers. What does that mean? It means that you can see that over here with 10. So why doesn't it say 5 or 1 nanometer or 2 nanometer, not micrometer? Why does it say 2 or 3? Why? Why does it do 3? Does it just feel good of putting 10? No, not exactly. And the same as goes over here, it has 200 micrometer. Why? Why does it do such a thing? Now, we have to understand is that when I talk about particle velocity, it's think about, as I kind of hinted you about kinetic energy, right? So kinetic energy, basically energy equals to 1/2 of mv squared, mv and mv. Energy, right? Energy, right? It's basically physics, right? So when we talk about energy, E equals to 1/2 of mv squared, M equals to mass, V equals to your velocity, right? So, and we need to have a certain amount of mass, weight, mass, right? So you can think about when we do spray, usually all of these powders, of course, we can get as small as possible, but at the end, we need to require a certain mass that allow these particles to have these mass that are able to have the gravity that plays into a role, right? So if the powder is too light, it's like weight nothing, it won't follow your trajectory when you spray. So that's why when we do a lot of spraying, usually we don't use nano-sized particle. It's simply because the trajectory when you spray out, if you might think that it will go vertically,